So let's just have a look at why we're doing this together. We've been spending our time up to now looking at smaller networks and getting those networks going, but now we're looking at larger networks, interconnecting different sites. So you could have the main site, a remote site, a small office, home office. We've got various types of internet connections and all that sort of stuff going on. So we're going to look at how we're actually connecting those wide area networks. The most important thing to remember is modularity. So we've got this lovely core model, this lovely hierarchical model that Cisco want us to use, and it's actually really good and efficient. The core layer of this three-layer model is all about moving traffic from one side of the network to the other side of the network as fast as possible, high-speed switching. The distribution layer is about connecting people and policy control, blocking traffic where it's meant to be blocked, allowing traffic where it's meant to be allowed. The access layer is where people, users, devices, wireless, phones connect in. It's where they access the network. So core, high speed, switching, distribution layer, policy control, access layer, connectivity. But now we're going to explode that model out even larger. So now we've got all three of the core, distribution, access. That's just inside our enterprise. Now we have links to the internet. We've got firewalls. We've got VPN concentrator. We've got dedicated routers for site-to-site links, e-commerce, multiple ISPs, possibly an old-school public switch telephone network, or even dedicated Ethernet, WANs, ATM, frame relay, etc. So we've got to look at connecting our sites. Switching. Switching is a big important part of our network, and we have to think about different types of switches and what they can offer us. Small switches for your campus, larger, more chassis-based switches for your data center, service provider switches who are just connecting you from one side of the city or one side of the country to another, virtualized networking, and cloud management. Cisco and Meraki have come leaps and bounds with their cloud management platform in the recent years. And when you're looking at what switches you're going to buy, very important factors: port density, power consumption, port speed, and whether or not they scale. All these different things are important when buying your switching. Something else that's really important, that's Cisco leading the way in again, is modularity of the back of the switch. So this is a slightly older graphic, but it shows the 3750 family, and the top switches have got a fixed power supply and fans, but the ones underneath it have got a modular fan and a modular power supply, and the very bottom one shows that you can actually buy an even bigger power supply. So if you've got a PoE switch and you're providing a whole bunch of phones, and then you suddenly realize, well, actually I want to upgrade those phones, so now I'm going to have color phones for everybody. That needs a lot more power. So rather than just throwing that whole switch away and replacing it, you can just upgrade the power supply. And it's really great for failures. I must admit personally, over 90% of all the switches I've replaced, power supply has been the factor. So now they're modular, you just swap it out in 5 seconds. The other brilliant thing which is going on is the stackwise. So you can see on the left, we've got those silver cables. This is, like I say, slightly older technology, and this operates up to 32 gig. So you can have 9 switches in a stack, and those switches now logically bond and become a single entity. And that stackwise cable bonds them together into a single management. The newer switches, the newer version, not only has stackwise for the data, but they also have stack power, so you can actually share the power supplies. So you've got 4 switches in a stack, you bonded them together into a single logical unit, and then one of the power supply dies. Well, the power from the other 3 switches can actually provide more than enough power to keep that 4th switch going. So you just go out there, you get an alert, go out, swap the power supply, and there's zero outage. Stackwise, very, very useful. Now, routers. The power of our router, the strength of our router. Are we just connecting a handful of computers in 2 different places? Do we need that router to have lots of policy or access lists implemented? More CPU? Do we need a router to connect between 2 different buildings? Do we need routers to connect lots of people with multiple routing protocols? And different media types. Do we have Ethernet? Do we have serial? Do we have frame relay? And there's many other factors to think about when you're choosing a router. When you're managing your equipment, you need to also think about how you're going to manage that equipment. Of course, fresh out of the box, factory reset, the console port is still the only way you can manage your router for the first time, and that is called out-of-band management because it does not compete with user data. And if you've got an old school an old school router that has an auxiliary port, you can actually plug a modem in there, and then you can actually just ring up that phone number, the modem will answer, and you'll be straight in as if you're on the console. These are out-of-band managements. You have to be physically plugged in. In-band management is just your typical SSH or Telnet or even a web browser. However, this is fighting or competing with user traffic. So you don't want your router to have to choose between servicing your requests for management and actually forwarding user data. But there are times when you have to. You've got a router in another building and you're not going to get your laptop and walk over there and plug in. Stay at your desk, use SSH, you're good to go. Configuring your router. Exactly the same as what we've seen in the previous module. First thing we've got to do, give it a host name, set up all our passwords and security, configure our IP addresses, set up a routing protocol, banners, interface descriptions, all that sort of stuff. This is nothing new, all part of CCNA 2 or Routing Switching Essentials. You've done this many times before. Just remember your interface descriptions, always handy. But as you see there, we've got a little bit of OSPF. We're going to spend a lot more time on that coming up soon. Basic switching commands. Sorry, basic router show commands. Show IP protocols, show IP route, show IP OSPF neighbor, show IP interface, show IP interface brief, show CDP neighbors. These few commands are the building blocks of all of your troubleshooting. If ever anything doesn't go the way you think it's meant to go, don't just do a show run every time. This is a far more targeting approach. Show IP route, show IP protocols, show IP interface brief, show CDP neighbors. These 4 commands are going to give you 90% of all of your troubleshooting. And once we start doing routing, that's where your OSPF comes in. And of course, all these commands, if you want the IPv6 versions, just do show IPv6 instead of show IP. Exactly the same command. Configuring a switch. Very similar to configuring a router. We've still got our host name, we've still got our passwords, we still need to set up a banner, we still need to set up our security, but instead of configuring our physical interface with an IP address, we configure our virtual interface. Our switched virtual interface is what takes that IP address. Remembering that on a layer 2 switch, the only reason why you give it an IP address is for management. This switch is not routing user data, it's only switching at layer 2. So the only reason why you give an IP address is for remote management. IP address, subnet mask, and default gateway. And later on we're going to be having a look at port security. That's why we've got switchport port security in there. Let's have a look at that now. Port security, very important factor to securing your network at layer 2. So we've got show port security, show port security address, show interface, show MAC address table, all the MAC addresses that have been learned, CDP neighbors, exactly the same. And show interface status. I like to think that on a router, show IP interface brief. On a switch, show interface status. Gives you exactly the same sort of thing. Now, let's just dive just a little bit deeper into the switch commands just for a few minutes. MAC addresses. So if you go to the MAC address, type in MAC address table, these are some of the options you've got. Aging time, how long to remember a MAC address. Secure, set up your security. Or static, you can even configure an interface to say, you know what, this interface has got this MAC address and this MAC address is always going to be on this VLAN. And therefore the switch doesn't have to learn anything, it knows that. So if anyone tries to move that PC or server to a different port, it's just not going to work. Because the switch says, no, this MAC address must be on this interface. So if you don't want that to do that, like all commands, if you want to get rid of it, just put a no at the front. Port security, very big factor in this module. So, go into interface mode, switchport port security, we've got 5 options. Notice that carriage return is the final option. One of the biggest things that people often forget with switchport with port security is you have to turn it on. You can set up your aging, you can set up your violation, you can set up the maximum MAC addresses, you can set up the MAC addresses you want to learn. But unless you turn it on, it's not going to do anything. So you have to go switchable port security, enter. Then you set up your maximum on your aging and your violation control. So let's have a look at some of these commands. When a switch port decides that port security has disabled that port, it actually goes into a state called error disable. And that's as good as shut down. Now, that will stay in error disable forever, or until that switch loses power. So as a network administrator, it's in your best interest to actually think, you know what, let's have some automatic recovery set up. So I've given you two commands there, error disable recovery 600 and error disable recovery cause security violation. So this will attempt to recover from a security violation in 10 minutes. So the interval is in seconds and the cause is what caused it. So just for fun, next time you're doing a lab, do error disable recovery cause question mark and see how many different things can make something go into error disable. Now just for fun, there's a little shortcut I've given you there, switchport host. It sets it up for, it's a shortcut to give you two commands, switchport mode access and spanning tree port fast. We'll talk a bit more about spanning tree in a little while. Now, switchable port security, so now we've turned it on. By default, the maximum allowable MAC addresses to be learned is 1, and if more than one MAC address arrives on this interface, the port will go into shutdown. The error disable will go into shutdown mode. These are the defaults. So if you type these in the running config, they will actually they won't be there because they're the default. So there are two other sorts of violations which are useful, and one is protect, and the next one is restrict. So the interesting thing about, we can talk about the difference between restrict and protect in a minute. Here's another good one though, switchport port security MAC address sticky. When a port learns the MAC address, it only remembers it while it's in use. So 10 minutes after that MAC address has gone away, it's forgotten about. But with switchport port security MAC address sticky, that actual MAC address is added to the running config. So you could turn on 20 computers and let them all be learnt by the switch with switchport port security MAC address sticky, do a copy run start, and then those MAC addresses will be learned forever. Someone could not use a PC for a week, and if they try and plug it in somewhere else and turn it on, the switch will say, no, I'm terribly sorry, that MAC address has already been learned and it can only survive and exist on this interface. So let's have a look at the difference between protect, restrict, and shut down. The biggest difference between protect and restrict is the messages. So when you set up a switchport port security violation restrict, every single time a violation happens, it will increase the messages in the syslog on your console and increase the violation counter. Now, because you might want to know about these things instantly, so you'll be setting up a log server like Splunk or something like that, and as soon as you start getting violation messages, you can get alerts. But if you're in some sort of library or education environment and you just want to lock things down, then just set it to protect, and therefore it'll do its job. Just a note too about the MAC addresses. Switchport port security maximum 1. Now if we say switchport port security maximum 3, and we say switchport port security violation restrict, then that port is going to learn 3 MAC addresses. And as soon as the 4th MAC address comes along, that's just going to be thrown away. But the best thing about protect and restrict is that the interface stays up. So if someone plugs in a little hub or something and then they plug in their laptop and they start working away and then they plug in a couple of other things, the very first few MAC addresses that are learned will keep working. But all the MAC addresses after that will just be thrown in the bin. And that's what we want. We don't want the bad traffic in our network. This will also protect us from things like DHCP snooping or starvation attacks, all that sort of good stuff. Now, a little point too for IP telephony. If you're setting up port security for your users who need IP phones, technically the phone has 1 MAC address and the PC has 1 MAC address, so you want us to do switchable port security maximum 2. But in reality, what happens is the phone, when it very first wakes up, it's on the access VLAN, and then it moves over to the voice VLAN, and then the PC begins to talk. So a bit of a best practice to set your switchable port security maximum 3 for IP telephony. Alright, thanks very much for your attention, and we'll see you in the next one.